All right, guys, last set of notes for exponentials and logarithms is some more application problems. So we're going to be using this general equation for exponential growth and decay. So go ahead and copy this down. Okay, y equals y sub 0, or y naught, times e to the RT. I'm going to go ahead and write down below what each part means here. Okay, so y is going to be equal to the final amount. Y sub 0, or y naught, is the initial amount, or your starting amount. E is just the number e, right? And then we have r and t. So r is going to stand for the rate. T is time. And before, like when we did that equation to figure out how much money we had in the bank, for time you always had to keep it in years. For this, we don't necessarily have to be in years. So if they give you 3 months, you can just use the number 3. Okay. So here is our first problem. It says the projected world population in billions of people t years after 2010 is given by this function. What will the world population be at the end of 2015? So we need to figure out what t is going to be. It says that t is the number of years after 2010. So since they're asking about 2015, t is going to be equal to 5. 5 years after 2010. So on this one, it's really just asking us to plug in 5 for t. So you can do this in your calculator, really just at once here. We should get 7.2, okay? And remember, they're talking about billions of people. And there's our answer. Second one, in what year will the world population reach 8 billion? So now they're telling us F, okay, 8 billion people. So we're going to plug in 8 for F, and we need to solve for T. Okay, so we need to get the exponential by itself. So the first thing we need to do is divide by 6.947 on both sides. I'm going to go ahead and just leave this as a fraction, because I don't want to start rounding too much here. So this kind of goes back to solving exponentials, right? How do you undo an exponential? You have to use a logarithm. Since the base is e, to get rid of that, I need to take the natural log of both sides, which will undo that. So I'm left with, right now, natural log of, again, just 8 over that 6.947 equals 0.00745 times t. So then our last step is going to be to divide by this decimal to get t by itself. So what you're plugging into the calculator here, we have t equals natural log of 8 over 6.947 all over 0.00745. You should get 18.94. Okay. The question, though, is asking, in what year will this reach? Okay, 8 billion. So what we need to do is add that to that 2010, right? Which gives us, so I'm just doing 2010 plus that 18, so that gives me 2028. Good. Next type of problem. So it says an initial amount of radioactive substance, y sub 0, is given, along with information about the amount remaining after a given time t. For an equation of the form y equals and that models the situation, give the exact value of k in terms of natural logarithms. Okay, so we're going to be using the equation they give us, and we're going to plug in the numbers where they need to go. So the first thing it gives us is y sub 0. So again, I'm just going to copy down the equation here. So y sub 0 is 40. 2 hours, so that would be time. And then this 30 is what remains. So I'll have 30 equals 40 times e to the k times 2. So I need to solve for k. I need to leave it, or I need to find an exact answer here. So our first step is to divide by 40. Okay, so that simplifies down to 3/4 equals e to the 2k. And just like before, to get rid of e to a power, I need to take the natural log of both sides to get rid of that. So I have natural log of 3/4 is equal to 2 times k. So now I just need to divide by 2. Now I think the way the book writes it, it moves that as like a fraction out in front. So they would write it as 1/2 times the natural log of 3/4. Okay, but you can really leave it as either. I just wanted to show you in case you were a little confused when you check your answers in your book. Good. Next one, it's similar. It's using that same equation. They give us different information though. So again, I'll set this up. Y equals y sub 0 times e to the kt. So the initial amount is 50, and then it says the half-life is 180 days. So half-life is talking about the amount of time that it takes to get to half of its original amount. So in this case, t is going to be equal to that 180, and since the initial amount is 50, I need to cut that in half, which gives me 25, and that's going to be my final amount. Okay, so I'll have 25 equals 50e to the k times 180. And we're going to solve it the same way. So now the 25 over 50 is just 1/2 equals e to the 180k. Take the natural log of both sides again. So I have natural log of 1/2 equals 180k divided by 180. So my final answer here, k equals 1 over 180 times the natural log of 1/2. Okay, and again, we're leaving it like that because it tells us to find the exact value. If I plugged that into my calculator, I would get a decimal answer. Good. Next one, again, still using this equation, a little bit different type of problem. It says if 800 grams of radioactive substance are present initially, and then 2.5 years later, only 400 grams remain, how much of the substance will be present after 4 years? So let's see what they're giving me. The initial amount would be 800. My final amount would be 400, and they're giving me a time. This allows me to solve for k, which is what I'm going to need to do first. Because then they're asking me, okay, how much is left after 4 years? So I need to figure that out in a second. First thing I'm going to do is solve for k. So if I plug in my numbers here, I'm going to have 400 equals 800 times e to the k times that 2.5 that they gave me. So I'll divide by 800. Again, take the natural log here. And then divide by 2.5. Now this time I am going to go ahead and find a decimal answer because I need to be able to plug it in to find the second part of the problem here. So this is what I need to plug into my calculator. Okay, natural log of 1/2 divided by 2.5. When I do that, I should get negative 0.2773. Okay, so that gives me the value of k, because now it's asking me how much of the substance will be present after 4 years. So I'm still going to use my initial amount of 800. and I'm trying to figure out how much will be left. So I have 800 times e to the, now I know k is negative 0.2773 times the 4 years. This I can plug right into my calculator. I get about 264, we're talking about grams here, so about 264 grams will be left after 4 years. Good. And then last type of problem, which I think is super interesting. You can go ahead and read through that paragraph, but carbon dating, if you haven't heard of it, you probably have heard of it in your science class. It is a way of determining like the age of a set of remains by comparing the amount of, it's called radiocarbon, with the amount present in a living plant or animal. Okay, so I don't know, I think just this is so cool. Here's the equation, so go ahead and write that down in that box. For this type of problem, y sub 0 is going to be the amount of that radiocarbon that is present in a living plant or animal. All right, t is going to be the number of years still. So, here's our problem. Suppose that the skeleton of a woman who lived in the classical Greek period was discovered in 2005. Carbon-14 testing at that time determined that the skeleton contained 3/4 of the carbon-14 of a living woman of the same size. Estimate how many years ago the woman died. So this one's a little bit different because it doesn't give us the initial amount and the final amount, or the amount in the skeleton versus the amount that a woman would have today. And so when you are like using the y and the y sub 0, you kind of want to think of it as a fraction. So the y, the final amount, is like 3/4, and the initial amount you would just put 1 because that's like the total. The rest of it you would just fill in. So e to the negative 0.0001216 times t. Okay, so if they give you a fraction like that, basically you're just plugging the fraction in for y, and then the y sub 0 is always going to be 1. Okay, so you don't really need the 1. You can kind of ignore it. Once again, we need to solve. We need to get rid of that e to the whatever, so we need to take the natural log of both sides. I'm going to have natural log of 3/4 equals negative 0.0001216 times t. So then to solve for t, you just need to divide by this. So go ahead and plug this into your calculator. And we'll go ahead and round. It says estimate how many years ago the woman died. So about 2,365 years ago. All right, that is it for the applications notes. Here is the homework. Yeah, thanks guys. Talk to you soon.